Loops allow you to perform a piece of logic multiple times using a single block of code. Let me show you how that works. Before we get started, if you find this video useful or if you have any questions, I would love to hang out with you. I stream on Twitch every Monday, Wednesday, and Friday. You can also find me on Discord. The links for those are in the description down below. Now then, there are multiple types of loops, but the two that you will use most are the for loops and the while loops. For loops are best suited to situations where you know how many times you need a piece of logic to run. For example, consider a situation where you want to print a message 10 times. Each message will say current message number and a number from 0 to 9. You can see how that would work on the screen. A for loop is broken down into 4 parts. After the word for, we declare a number variable called I and set it to 0. The variable name of I is not mandatory. This variable can be named anything, but I is the standard and can stand for either index or iteration. The variable determines the current step of the loop we are in. The second part is the condition determining when the loop ends. For our example, we state that as long as the variable I is less than 10 to continue the loop. Once the variable I is 10, the loop ends. This is also called breaking out of the loop. The third part is what determines how the index variable is updated each time the loop's body is run. In our example, this is indicated by I++. Just like in the earlier video on working with numbers in JavaScript, adding plus plus to the end of a number variable adds 1 to the current value of the variable. It would be the same as stating I equals I plus 1 or I plus equals 1. In the same way, adding minus minus to the end of a number variable subtracts 1 from the current value of the variable. It would be the same as stating I equals I minus 1 or I minus equals 1. The fourth part is the loop body. The loop body is everything contained within the curly braces and is the logic we want to run repeatedly. Oftentimes, you will perform some kind of action over every element of an array. We can easily get the number of elements in an array using the .length command. For example, if you have an array called employees and you want to know how many employees are in the array, you would simply call employees.length. As a more detailed example, consider a situation where you want to print the name of every user in an array of JSON objects called users. You would see how that would work on the screen here. Notice that the loop looks nearly identical to the previous loop. In this example, the ending condition is that the variable I is less than the length of the user's array. This is hugely beneficial because the ending condition of the loop is now dynamic. Regardless of how many elements are added to or removed from the array, the loop will always cover every element. Please note, however, if you add or remove array elements within the loop itself, the loop may not behave in the way that you want it to. For example, if you are looping through the user's array, it's not a good idea to add or remove elements from the user's array within the loop body. You may, however, add or remove elements from a different array within the loop body if you have a situation that calls for it. Notice also how the loop body prints each user's name. We see this achieved by printing users with square brackets I dot name. The I within the square brackets is the current value of the I variable we created in the beginning of our loop. This is also hugely beneficial because it allows us to dynamically access each element of our array based on the current step of the loop we are in. For example, if we are in the third step of the loop, we will access the third element of the array. It's also possible to put a loop within a loop. This is called a nested loop. And a nested loop looks something like this. The outer loop will run for 10 times, and the inner loop will run for 5 times on each step of the outer loop. This means that a total of 50 actions will take place. And that is one of the main reasons that you should avoid nested loops whenever possible. They quickly increase the amount of work your program needs to do over a short period of time, which can make your program run slower. For a small number of steps, like 50, this isn't a problem. When you consider thousands of steps, however, this can definitely be a potential problem. To be clear, I am not saying nested loops are bad. I'm saying that you need to be careful with them and only use them when necessary. When are they necessary? Unfortunately, knowing that comes with experience and trial and error. The best advice I can give is if you see a situation where a nested loop could be used, take a moment to consider how you might write your code in a way to avoid using a nested loop. If no reasonable alternative can be made, then the nested loop is necessary. In my own experience, there have been times where I've needed to make nested loops up to 5 layers deep. So that means a loop within a loop within a loop within a loop within a loop. Now let's move on to while loops. While loops are best suited to situations where you do not know how many times you need a piece of logic to run. For example, consider a situation where you want to search the users array for a user named Bob Ross and update his age when he is found. You can see how that might work on the screen. While loops are broken down into 2 parts. After the word while, we define the conditions that the loop will continue to run. In our example, so long as user found is false and user index is less than the user's array length, the loop will continue. If either of these conditions are no longer met, the loop will end. The second part is the loop body. The loop body is everything contained within the curly braces and is the logic we want to run repeatedly. Even though while loops are easier to write, they are also easier to break. Where a for loop contains everything you need to run the loop when you define it, a while loop requires you to define variables to track the loop conditions outside of the loop definition. You also need to make sure you update those variables within the loop body. Otherwise, the loop will run forever. Such loops are called infinite loops. Infinite loops happen when the ending conditions of the loop are never met. Infinite loops will steadily consume your system's memory or CPU until it slows to a crawl. The only way to stop an infinite loop once it starts is to either close the program and/or stop its process in the task manager. They can occur in both for and while loops, but they happen much more frequently in while loops. In while loops, an infinite loop can occur in 2 main ways. For one, an infinite loop can occur when your loop breaking conditions are incorrect. For example, you can set your ending condition as a variable being less than a specific number when you intended to track if the number is greater than a specific number. An infinite loop can also occur when you do not update the variables necessary to end the loop. Because while loops require you to manually create and manage the variables necessary to end the loop, It's very easy to forget to update these variables in the loop body. In for loops, an infinite loop can occur usually in one of two ways. An infinite loop can occur when you set the ending condition incorrectly. It's very easy to put I is greater than users.length when you intended to put I is less than users.length. An infinite loop can also occur when you set the index variable update section incorrectly. One of the more common mistakes here is to put I minus minus when you intended to put I plus plus. It's important to note that infinite loops can be difficult to detect in your code because the syntax of your code is technically correct. The problem lies in the code logic. Therefore, your IDE will not yell at you or warn you that something is wrong. The compiler simply assumes that this is what you intended to do. So it's imperative that you are careful with your loops. And that just about covers the basics of how to use loops in JavaScript. In the next video, we'll talk about how to run sections of your code on command using functions. If you found this video useful, like and subscribe so you can be notified of future videos. If you have any questions about anything covered in this video, feel free to catch me on Twitch or Discord, or leave your question in the comments. Thanks for watching, and stay awesome.